Hey guys, welcome. Today I want to show you how you can set up enemy projectiles so that they can be deflected back towards the enemy. This is a really fun one and it feels awesome to use. I'll also show you how to tackle ignoring collisions between two objects, and as a bonus, at the end, I'll show you how we can use AnimationCurves to directly control the speed of our bullet, which is super easy to set up and allows for a lot of control and customization. Let's get started. Okay, and here is our simple scene. The things that you'll want to make note of are that we have a player with the ability to move and jump and attack. We also have an enemy in the scene with an enemy health script. Now the enemy health and the player health script are both very, very simple, but I will walk you through them because in order to properly show you how to set up the ability to deflect enemy projectiles, well, we need a couple of things in the scene. We need an enemy that can be damaged, we need a player that can be damaged, and we need a player that can attack. And we'll set up the enemy shooting in this tutorial because that's going to be very, very easy and quick. For the enemy, I've got a max health that I've set to 3. I've also got a private float called current health. In our start, we set the current health to be equal to the max health. And then in our damage function, we subtract the current health by our damage amount. We spawn in some particles and then we check if the current health is less than or equal to 0. And if so, then we destroy the game object. Very, very simple stuff. And the player health script is virtually exactly the same. Now, the thing of note here is that both the enemy health and the player health are implementing from the damageable interface. And I'll show you that. That's right here. It's a very, very short and very easy script, public interface damageable, and we've got a blank method in here. So this enemy health, public void damage, and this player health, public void damage, these damage functions are from the damageable interface. And it's important that we set it up this way because we want the enemy projectile to have the ability to damage both the enemy and the player. And we don't want to do this by checking for tags or anything like that. We want to do this right. So the enemy projectile is going to be looking for the damageable interface and call the damage method from there. And if you found that a little bit hard to follow, that's totally fine. You'll be able to see how this works in better detail very, very soon. It'll all make sense once it's pieced together. I may grab 1 or 2 assets from this tutorial asset pack here. I will leave a link to download these in the description below. They are yours to do with what you want. They are totally free. You can use them personally or commercially. It's just a great little set of assets to get you started in game development. I hope you enjoy. So we have a player with health. We have an enemy with health. Our player has an attack function. And let's now set up the enemy actually shooting projectiles. I'm going to create a new script called enemy shoot. And I would like to add that onto my enemy game object. Let's open that up. So what I want to do in here is spawn some sort of bullet into the scene after a counter has reached a certain amount of time. So let's get the counter set up first. We'll want an update function for that. I'm also going to set up a serialized field, private float time between attacks. And let's default that to 2 seconds. So every 2 seconds, we're going to spawn a bullet into the scene. Let's also set up a private float shoot timer. Now first, let's update our timer. So we're going to do that by saying shoot timer plus equals time.delta time. And then we're just going to say if our shoot timer is greater than or equal to time between attacks. So our shoot timer has now caught up to time between attacks. Well, first we're going to want to reset the timer and then actually shoot the projectile. So to reset our timer, we'll say shoot timer is equal to 0. And to shoot the projectile, we'll call some sort of shoot function, which we'll create right now. Now, we know in here we're going to want to spawn a bullet, but I also want to directly set the velocity of the bullet inside of this shoot function. I would normally separate this logic out, but to keep this tutorial very easy and fast, we're just going to set it right here. And I'll show you actually a really cool trick to do that. So to spawn the bullet, we are going to use the instantiate function. What do we want to instantiate? Well, let's go up here and set something up. Serialized field, and we're actually not going to do private game object. We are going to do private rigid body 2D and call that bullet prefab. So we're going to instantiate that bullet prefab at the enemy's transform.position is totally fine. And we're also going to pass in the enemy's transform.rotation. So we instantiated a private rigid body 2D. Now, how do we actually manipulate that? Well, let's go up here. Let's set up a private rigid body 2D called bullet RB. Now we can just say bullet RB is equal to instantiate all of this. What we have just done by doing that is we now have a reference to the bullet's rigid body component, which I just find that really cool, where you don't have to do a get component call or anything like that. You just grab it directly while instantiating it at the same time. Now to set the bullet's velocity, we're just going to say bullet RB dot velocity is equal to bullet RB dot transform dot right times some sort of speed. And let's set that up here too. Serialized field, private float bullet speed. Let's default that to 15, and we can throw that down here. Now let's go ahead and test that by setting up an actual bullet prefab. So back in the editor, I am going to go into our tutorial asset pack, and I'm going to go into weapon, and I'm just going to grab this primitive capsule right here. And I know that you can go here and say 2D object, sprite, capsule, but the reason that I want to bring this one in here is because it's pointing to the right. If you're ever working with projectiles in Unity, it's always easy if you have the actual sprite with the bullet drawn pointing to the right. I'm going to take this and rename it to enemy projectile. I also set up a layer called enemy projectile. I'm going to set it to that. I'm also going to change the scale to 0.3. I also want to throw a capsule collider 2D on there. I'm going to change the direction to horizontal and get that to fit. And let's make that a trigger. And let's also add, we know we definitely need a rigid body 2D on here. So dynamic is fine. Let's get rid of angular drag and gravity. As long as our bullet's not going too fast, collision detection mode discrete should be fine. Continuous is a lot more expensive, so it's best to use discrete when you think you can. And let's set interpolate to interpolate. And we know we're going to need to set up some sort of script on here that's going to apply damage. So I'm going to set up a new script called enemy projectile. And let's drag that on there. And before I forget, I'm going to go ahead and turn this enemy projectile into a prefab now. And let's open up enemy projectile. So we set this collider up as a trigger. So let's go ahead and call the onTriggerEnterToD function. And this is where we actually want to call some sort of damage function, right? Well, remember, we want this bullet to be able to damage both the enemy and the player. And I don't want to set up if statements and check for if the tag is equal to enemy and if the tag is equal to player and grab those components that way. No, what we're going to do is we're going to go up here and we're going to set up a private iDamageable. Let's call it iDamageable. What we're going to say is that is equal to collision.gameObject.getComponent iDamageable. And if we actually find an iDamageable, and we can say that by saying if iDamageable is not equal to null, then we'll actually apply damage by saying iDamageable.damage. And it's going to ask us for our damage amount. Let's just set that up here. Serialized field, private, float, damage amount. Let's set that to 1 and plug that in right here. So now again, because our enemy health script is implementing the iDamageable interface and our player health is also implementing the iDamageable interface, this is now going to work on both or any other script in our game that implements iDamageable. If you've got breakable objects in your scene, you can add an iDamageable to scripts attached to those game objects as well, and this will also damage those. It's a really great way to handle damage. So to test that, let's delete this out and let's go back to our enemy and actually assign our bullet prefab there. So you can see that it's working, but we have an obvious problem. The enemy just killed himself. Now we want these bullets to be able to apply damage to both of these. And really right now, if you think about it, this makes perfect sense. We are spawning the enemy bullet right here in the middle of the enemy's box collider. And then it's going forward and it's actually triggering and applying damage to the enemy. So one very quick potential fix for this would be to go to edit down here in our project settings, make sure you're on physics 2D and go down here to our layer collision matrix. So right here, we can actually turn off collisions between the enemy projectile layer and the enemy layer right there. You can see with that change applied, you can now go back in and damage is only being applied to the player and the enemy is not damaging himself anymore. However, this is not really a good solution for this use case because these are project-wide settings right here. This is a really great place to disable collisions between certain layers that you know in your entire game, they're never going to be interacting with each other. This is a great tool for certain use cases, but for this, where we want the bullet to be able to be deflected back at the enemy and damage him, this is definitely not a good way to do that. So let's turn that back on and we are going to have to find another way to do this. So what we're going to do is set up some sort of method that is going to give us the ability to ignore collisions between this bullet and the enemy that shot the bullet. So I'm going to set up a private void called ignore collision with enemy toggle. And in here, what we're going to say is if physics2d.getIgnoreCollision. So we are asking, are we currently ignoring collision between collider 1 and collider 2? What are those colliders going to be? Well, one is going to be this bullet's collider and the other is going to be the enemy collider. So before we can finish this, we are going to need to get a reference to both of those. The bullet collider is very, very easy to get. We'll just go up here and we'll say private collider 2D. We'll call that call and we'll set that in our start function. call is equal to get component collider 2D. So we already have a reference to the bullets collider, but figuring out how to get a reference to the actual enemy's collider, particularly the enemy in the scene that shot this bullet. So how are we going to do that? Well, we're going to go up here and we're going to set up a public collider 2D called enemy call. And I made the E in uppercase because we are going to set a public getter and a public setter. Public get means that any other script can access this reference here, and public set means that any other script can also set what this enemy collider actually is. And we want this to be a public set because we are going to set it within the enemy shoot script. So currently this is not anything, but now that we've got these two variables up here, we are actually able to finish this method down here. So let's do that first. So are we currently ignoring collision between call and enemy call? And actually, I want to say if that is false, then I want to turn on ignoring collisions. And we'll do that by saying physics2d dot ignore collision call enemy call true. And then we'll say else turn off ignore collisions. And we'll do that by saying physics2d dot ignore collision call enemy call false. So now every time we call this, it's just going to toggle between on and off every time. And I actually want to call this right here in our start function, because our problem was we are respawning the bullet right inside of the enemy itself, and then it's applying damage. But if we set this in start, if we actually ignore the collision between the bullets collider and the enemy collider in start, then this is not going to get called for the enemy. And that is because in Unity's order of execution, the start method is called well before the onTriggerEnter2D function down here. So we know based on this chart here that this gets called well before this, which means we know that this is going to get called, and this will not get called on the enemy when the bullet is first spawned into the scene, which is exactly what we want. Now, I'd like to be able to test this, and in order to do that, we first have to actually set what this enemy collider is. So let's go back into our enemy shoot script. And we are actually going to handle all of this in the shoot function as well. We'll first need to grab a reference to the enemy projectile script, and then we'll actually set the enemy call collider. So let's set up a variable up here for enemy projectile, private enemy projectile. Let's call it enemy projectile. So we're going to say that is equal to bulletrb.gameObject.getComponent enemy projectile. So by doing it this way from bulletrb, we now have a reference to the enemy projectile script attached to the actual instance of the bullet that we spawned in, which is exactly what we want. So now we can actually grab the proper collider reference. So now we can say enemy projectile dot enemy call is equal to, well, what's it going to be equal to? It's going to be equal to this game object's collider. So let's grab a reference to that really quick. Private collider2d, let's call that call. Let's grab that in a start function. Call is equal to get component collider 2D. Now we can go down here and say enemy projectile dot enemy call is equal to call. All right, let's test that now. Awesome. You can see that the enemy is now shooting, but he is no longer damaging himself. Perfect. So now we want to make this projectile deflectable. Well, let's do that in a very similar way to applying damage. Let's set up an interface for that. I'm going to go into my interfaces folder and create a new script called Deflectable. And we do not need mono behavior or the colon. It's not a class, it's an interface. So we're going to set up a blank method called public void deflect. And I would like to be able to pass in at least a direction. So let's add in a vector 2 called direction. And when you're creating an interface, you don't actually use the curly brackets on a method. This is going to stay a blank method because basically the details of the method are going to get filled in based on the actual classes that implement this interface. While we're in here, I'm also going to set up a public float called return speed, just so that we can very easily set these up wherever we actually implement iDeflectable. So to do that, we'll do that as a public get, public set. Okay, now to actually use this properly, we're going to go back into enemy projectile, and right beside mono behavior here, we're going to add a comma and add iDeflectable. That's going to give you an error because we need to implement both of the interface members. So really, you could come over here and you can copy and paste these, or you could go to your enemy projectile and you could right click here and go to quick actions and click implement interface. What that'll do is actually set up a public float return speed. And right here at the bottom, it's set up a public void deflect. I'm just going to get rid of that. And up here, I'm going to get rid of all this junk here. We're just going to make it match. So public get, public set. I'm actually going to go ahead and default that to something like 10. Okay, so now we have an actual deflect method in our enemy projectile. So what do we want to do in here? Well, this was called in start, so as soon as we actually call the deflect function, we probably want to call this toggle function again so that we actually turn off the ignore collision between the bullet collider and the enemy collider. So the bullet is able to damage the enemy again. Next, we want to change the direction of the bullet's velocity. And we don't actually have a reference to the rigid body in this script, so let's grab that. Private rigid body 2D, let's call it RB, and we'll grab that in our start function. Now we can go down here and say rb.velocity is equal to what? Well, we are going to pass in a vector2 direction here. So let's just say that our velocity is equal to the direction times our return speed. Okay, so we need to actually call this from somewhere now. And in the case of my project here, I want to call deflect when the player actually uses a melee attack on the bullet. Okay, so this is the player attack script, and it looks a lot more complicated than it actually is. Yours does not need to look like this, not even remotely close. What we do care about is where are you actually calling damage in your player attack function. If you're not sure how to apply melee damage in 2D, then I have an awesome tutorial you should check out. You'll know exactly what's going on here if that's the case. But really, what we care about is where are we actually calling a damage function, because we're going to put our deflect function basically in the exact same spot. So this whole section right here is me actually looking for eye damageables. Excuse me. So again, the specifics here of what is going on behind the scenes really doesn't matter. We just care about where is damage being applied. We're going to look for an eye deflectable in the exact same way. So I am going to look for an eye deflectable. I'm going to call that eye deflectable. And I need to do that the same as I did it up here because I am applying damage by using a circle cast all, which is returning a raycast hit 2D array. So hits of this index dot collider dot game object dot get component eye deflectable. So we are looking for an eye deflectable, and how you are going to grab this kind of depends on what method you are using. Again, I'm using a circle cast all, which returns the results into a raycast hit 2D array. So within a for loop where I'm actually iterating through everything that it found, we grab the current index and find the collider game object eye deflectable component. And then if the eye deflectable does not equal null, then we're going to call eye deflectable dot deflect. And it wants a vector2 direction. Now for me, this player attack is directly attached to my player game object, so I can just pass in transform.right. Meaning whichever direction my player is looking, that is the direction he is going to send the bullet. And now I have to add a couple of lines in here because of how I apply damage, because I have animation events going on. I have a couple of extra checks that you likely won't need unless you followed my melee combat tutorial. So I'm just going to add those in so my stuff works properly, but this may or may not be applicable for you based on your project. Okay, there we go. Let's give that a quick test. I'm actually finding the enemy bullet to be a little bit too fast. I'm going to slow that down to 10, but you can see that that's working. I am able to deflect the bullet back towards the enemy, and if I'm facing that way, it's just going to keep on going in that direction. Now, the problem with the way that we have set this up is this is entirely counting on the fact that this bullet is going to be going straight the entire time. But maybe we don't have such a boring stationary enemy that only shoots bullets in a straight line. So to make this a little bit more realistic, what I would like to do is have the enemy actually aim the projectiles towards the player so that even if we're jumping and we're like up here or something, the enemy is going to shoot towards where we are up there. So let's go back inside enemy shoot. And what I would like to do is set up a function that will allow us to very easily grab the direction from our enemy to the player. So what we're going to do is we're going to go down here and we're going to set up a public vector2 called get shoot direction. Direction is basically destination minus origin normalized. That is going to give you the proper direction. So we first need to grab a reference to the player's transform. So let's set up a transform, call that player trans. And that is going to be equal to game object with a capital G dot find game object with tag player. And before we finish, let's go to our player and make sure he actually has the tag player on him. So game object dot find game object with tag player dot transform. And because we set this up as a public vector 2, not a void, we need a return type. So we're going to return the player transform dot position minus the enemy's transform dot position dot normalized. So we can now easily call this from anywhere to grab the direction. Now our bullet's velocity is initially set as soon as it is instantiated, and it goes in the direction of the bullet's transform.right. So actually, to make this very, very easy, we can actually go up here and set the bullet's facing direction. We can say bullet rb.transform.right is equal to get shoot direction. Now that has actually changed and will face the bullet towards the player's position. And then we are going to set the velocity based on that new transform.right. Let's go ahead and test that out. So you can see now if we jump, he's actually going to aim towards the player, but now we have a new problem. The player is only going to deflect the bullet in a perfectly straight line, which is not what we want. That looks especially weird when it's up here. So let's change it so that the deflection will actually make the bullet return in its original trajectory. So what I want to do back in the enemy projectile script is, instead of passing in the bullet's velocity directly in the direction that we pass in on the deflect method, I would like to change that to transform.right. And we said we wanted the bullet to return in its original trajectory. So right before that, what we're going to do is say transform.right is equal minus transform.right. So that's just going to flip it right around, and then we're going to send it in its transform.right direction. Okay, so you can see that if I'm up here, it deflects back, but you can see if I hit it from this direction, it actually ends up going the wrong way, which we obviously don't want. So what we want to do is go up here and actually say if the hit direction is left and the current travel direction is right, or vice versa. We can do that by saying if the direction.x is greater than 0 and the bullet's transform.right.x is less than 0, or direction.x is less than 0 and the bullet's transform.right.x is greater than 0. If either of those are true, then we want to actually flip the transform.right. Let's test that now. Can deflect them that way, and if I hit it from this direction, it just keeps on going in the same direction, which is perfect. Now, to make this look a little bit nicer, I would love to be able to very easily control the velocity of the bullet, especially after it's been deflected, because maybe we want it to change direction very, very, very quickly and then start to slow down speed over time. Or it could be the opposite. It really depends on your use case and what you want. So what we're going to do is go back to enemy projectile. We're going to set up a serialized field. I'm going to say private animation curve. Let's call it speed curve. And now we're going to create a fixed update. You always want to be changing velocity in fixed update. It's really okay down in a function like this on deflect, where it's only being called one time. But if you're adding forces or you're changing the velocity consistently all of the time, you definitely want to be doing that inside of fixed update. So this is really, really cool. We are going to control the speed of this projectile after it's been deflected based on an animation curve. And we're going to need two floats for that. So we're going to set up a private float, one called speed and one called time. So back in your fixed update, our speed is going to be equal to our speed curve.evaluate. So it wants us to plug in a time. Well, we're going to plug in our time variable. Our time is going to be plus equal to time.fixed delta time. So we are incrementally updating our time float based on the amount of time since our last fixed update happened. And then we can say rb.velocity is equal to our transform.right times speed times our return speed. And the last thing we need to finalize this is we need some sort of check, because this can't be running all of the time. We only want this to be working after the deflect has been called. So let's go back into our iDeflectable interface and let's just throw in another public bool called isDeflecting. And we'll also make that a public get and a public set. And you can't go wrong with interfaces because as soon as you add something or you make a change, you're going to get an error, which is going to tell you that you are not implementing the interface member. And again, you can always add that by right-clicking, quick actions, implement interface. And that's just going to add our public bool is deflecting. Let's again just change that to a public get and a public set. So if we don't default that, it's going to default itself to false, which is fine. So we're going to go down to our fixed update and say if is deflecting, then we'll call all of this. And when are we going to change this? Right at the top of our deflect function. So we'll set that true right here at the top of deflect. Now, as soon as this is called, all of this is going to start running. So now if we go into our enemy projectile prefab, we've got this actual speed curve here. And if we click there, let's just start with one of these presets right here. By the way, if you're ever having trouble looking at these graphs, like getting it all to fit on the screen, you can actually zoom just the x-axis by holding the control button on your keyboard and scrolling with your mouse. And if you hold shift on your keyboard, then that is only going to scroll in the y-axis. So if you're having trouble getting it to fit, you can very, very easily make it happen like that. Now, just for the sake of example, let's just use this curve right here. It's going to start at 0 speed. And by the time 1 second has passed, we will reach full speed. There you go. Maybe a linear curve like that doesn't quite make sense to you. Maybe we want to start that up here at like 0.6. If we right click that and change that to free smooth, now I can drag this handle here to actually curve the line a little bit like that. So we'll start at 60% speed and very slowly amp our way up to full speed. There you go. Now that you know how to apply speed over time based on an animation curve, you can really start to smooth out certain mechanics in your game where you think it's going to be helpful. I love working with animation curves. They are awesome. And that is all I got for you guys today. Thank you so much for choosing this video to learn how to deflect enemy projectiles back at them. I really want YouTube to like me more, so if you guys found this helpful in any kind of way, then it would really mean the world to me if you would give this video a like and leave me a comment down below and let me know what you liked or what you would have done differently. You guys are really knowledgeable and I always love to hear how you guys would handle things. Honestly, guys, I hope that you have an amazing day. Bye.